I'm Anil Kumar, and in this video we will learn how to sketch a transformed sinusoidal function. So to begin with, we have taken a very simple function y equals to 2 times sine x minus 30 degrees plus 1. You need to sketch the graph of this function. To sketch the graph, we can follow two steps. In first step, we'll incorporate stretches, compressions, and reflection. And in the second step, we could do translations, both vertical and horizontal. I also prefer to use 5 points to sketch our graphs. Any sinusoidal function could be defined by 5 points. Let us say this is a sinusoidal function. This is just to explain you, right? And then we'll finally sketch it. So the points which I'm talking about are these points. So initially we have these 5 points on a sine function. So always sine function starts from a 0 and then it goes to the maximum 0, minimum 0, and in one cycle, right? So that is how it is. So this cycle is divided into 4 equal parts. So if this is t, here we have t over 2, and this one is t over 4, and this one is 3 times t over 4, correct? So that is how the sine function is, and this value normally will be just the amplitude and minus value of amplitude. So that is your vertically stretched, compressed kind of a function, right? So this is your first function normally, right? The second function will incorporate these translations. So let us first sketch our basic function. So what we have here is an amplitude of 2. Incorporate these stretches and sketch our graph. So what I'm trying to say here is that we'll sketch y equals to 2 sine x as the graph, right? So here what we have is a vertical stretch by 2, and the time period t is equals to 360 degrees for us. That is the default time period, and amplitude a is 2 for us. So let us divide the scale so that we can have 360 degrees. So let us say we have we can go with 30, 60, 90. 30, 60, 90, that becomes 180. 30, 60, 90, 270. 30, 60, 90, 360. So that is our 360 degrees. A sine function will start with 0 as we have discussed, 0. The maximum value will be that of the amplitude. So let us say the amplitude is 1, 2, 3. So let us say this is 1 for us and that is 2 for us. So the minimum value will be 1 and 2. Correct? So it starts with 0, goes to maximum, then comes back to 0, goes to minimum, so that is 2 divisions here, and goes back to 0. So once you connect these points, you get your cosine function. Do you see that? So this is 2 sine x, right? So that is your sine function. Okay, so this is always the first step. I should say not always, this is the preferred first step. Now to get the final graph, that is to say, we need to now incorporate the translations. So we'll sketch now y equals to 2 sine x minus 30 degrees plus 1. It really means that we have to move 1 unit up and 30 degrees to the right. 1 division is 30 degrees for us, right? And 1 unit is this much. This is 1 for us, right? This is minus 1. Here we can write 2 and minus 2. And let me complete this by writing 360 degrees, 180 degrees here, right? This is 90 degrees, and as you know, 270 degrees. So we'll move each point 1 unit up and 30 degrees to the right. So that means, starting from here, 1 unit up and 30 is 1 division, so that is my first point. 1 unit up, which are 2 divisions, then we get the second point. 1 unit up and 1 point. Third point, 1 unit up, which is 2 divisions, 1 right. 1 unit up and 1 right. So that gives us the transformed sine function. Do you see that? So we have a transformed sine function here, which you can sketch. Yeah. So just connect these points. So what you have here is your transformed sine function. Now it's a good idea to check your values. You should be expecting what maximum value. Maximum value is always 1 plus the amplitude, so which is 3. Minimum value is 1 minus 2, which is minus 1. Let us check. So this graph, we have minus 1 as the minimum value. Perfect. Axis. So axis is y equals to 1. So let me draw axis here. Y equals to 1. It goes through the transformed zeros. Do you see that? So this is indeed just the right graph for us, and this value is 3, which is maximum. So now you can also write domain and range for a cycle of the graph which we have sketched. I hope this simple process helps you to understand exactly how you should be sketching transformed sinusoidal functions. Thank you and all the best.